Good morning, people. Today, we have a very important meeting talking about disabilities and automobiles. Did you know that 22% of the US population of adults has some form of disability? And this can affect the way that they drive automobiles in many different ways. And we have a lot of creative solutions that we need to talk about. So, I brought in a very beloved friend. Hey, Prison Mike. We're going to talk about the importance of ergonomics. You should be scared straight about ergonomics and automobiles. It's a fundamental aspect of design, and it accounts for many different functions, including how people secure their seatbelts or how they maybe accelerate the gas pedal. People with disabilities such as muscular bone disorder or their amputees, these functions can be very difficult for them to perform. So, in order to account for these difficulties, automobile designers must take in data on different ergonomic criteria to make adaptations for these people. So basically you can make adaptations on steering, brake control, acceleration, driving seats, wheelchair accessibility, and potentially some additional indicators. All right, ideas. We need ideas. Jim, what do you got?
Well, there are many adaptations that can be made to create a better driving and passenger experience for those who are disabled or physically impaired. Some smaller ones include swivel seats, a seat that may rotate and lock. This allows for an easier entry and exit to the vehicle. Steering balls, an attachment to the steering wheel that allows the driver to safely control the vehicle with one hand. Pedal extensions, these provide a simple solution for those who aren't able to comfortably reach the pedals due to back, hip, and knee issues. Larger adaptations include left foot accelerator, a highly adjustable attachment that enables those without function in right leg to operate their vehicle. Push-pull hand controls. This enables those without function of their lower limbs to operate the brake and accelerator functions of the vehicle. Specialized seating, a rotating seat design that significantly reduces the amount of energy along with the risk of further injury when entering and exiting the vehicle.
All right, people, we still need more ideas.
Mike, I got an idea.
So, drop-by-wire systems were implemented into vehicles based on their functionality in fighter jets. A joystick or small wheel is used to control the system. Touchscreens are also essential. The goal is to allow for operators with limited strength or range of motion. The increase in technology allows for drivers with high levels of disabilities. The driving, steering, and braking aspects can be covered using the joystick or wheel. However, the secondary systems such as windshield wipers, blinkers, lights, and ignition need to be controlled using the touchscreen interface. Otherwise, it would be too difficult to implement. These user interfaces allow for maximum capabilities of the driver regardless of the level of disability.
That's good. That's really good. Now, we need more examples, real-world stuff. Ryan, you have anything?
Sam Schmidt is a former race car driver and quadriplegic. He became a quadriplegic after a crash during one of his races. Ever since the crash, he has always dreamed of driving again, and a company named Ergo made his dream come true. Sam is now one of the only quadriplegics with a driver's license to drive a semi-autonomous Corvette. The driver drives the car wearing a hat or sunglasses fitted with infrared sensors. Inside the car, infrared cameras are mounted facing the driver. These cameras and sensors are connected to a system that monitors the driver's movements in real time. The car is steered by the driver turning their head in the direction they want to move, and the system translates this movement into steering the wheel. To accelerate, the driver breathes into a mouthpiece that is connected to a free-scale pressure sensor that is fitted to the driver's preferred sensitivity. The system is connected to the gas pedal. The more pressure, the faster the car accelerates. Braking works in the same way. The driver will suck into the mouthpiece and the car will brake. If the driver wants to coast, then they will do nothing.
People, I love everything that you said today. You're all just the best people in the whole world. And so, some final considerations of everything we talked about with disability and accommodations for that. Really, the future is most likely going to be self-driving cars. There's already been a lot of advancement in that area, and it's only moving forward and progressing to be what will be the best solution for people with disability in a world where they wouldn't actually have to drive by themselves.